Welcome, deep divers. Today we're embarking on a really fascinating journey. We've got this incredible stack of sources you provided, and it's a remarkably diverse collection. We're talking project management, architectural history, building construction, even some philosophical takes on engineering. Yeah, you might look at these documents, technical guide here, some musings on medieval cathedrals there, and how does this all fit together? But that's exactly what we're here to do. Our mission, as always, is to pull out the most important nuggets of knowledge, the key insights, and kind of weave them together for you. Give you that shortcut to becoming really well-informed about, the built world that's all around us.
Precisely. And, while the topics might seem pretty disparate at first glance, there are these underlying principles that just keep emerging. Things like human endeavor, design, problem solving. They're really powerful, universal threads. So we're going to explore how careful planning, the choice of materials, the historical context, even just the human experience itself, how all that is deeply intertwined in creating our built environments. This deep dive, it really aims to reveal those invisible forces shaping the world around us.
Get ready for some serious aha moments, I think. Because here's where it gets really interesting. You'll start seeing the buildings you use every day in a totally new light. Hey, let's kick things off with something that's just fundamental to any big project, right? Teamwork. I mean, when we talk about bringing anything significant to life like a skyscraper or even new software, it's never just one person, is it? Or single blueprint. The sources really hammer home the power of, working together.
Oh, absolutely. And what's fascinating here is this specific concept they talk about, a collaborative project team environment. It's not just, being nice to each other. It's described as fostering a free exchange of information and individual knowledge. And that free exchange, that's the key part. It directly leads to shared learning and individual development while delivering outcomes.
Shared learning, yeah.
Yeah. So it's not just a feel-good phrase. It's fundamental. Everyone needs to contribute their best efforts to get those desired results. The idea is that the collective brain power, when it's working properly, is just way more effective than individuals working in silos, you know?
Right. So it's not just about hitting the deadline or the budget target. It's also about doing it in a way that respects and enhances an organization's fundamental values, principles, and culture. That sounds pretty holistic. Like the process matters just as much as the product. And it feels like there must be some guiding principles involved to keep it all aligned.
Exactly. The sources point to the importance of incorporating practice standards, ethical codes, and other guidelines. These aren't just rules for rules' sake. They're crucial support systems. They help teams avoid potential conflicts between different disciplines. You've got architects, engineers, contractors. They all kind of speak slightly different languages sometimes. So these standards create a common framework, a shared understanding, so everyone's pulling in the same direction.
Makes sense. A common language. Hashtag 1.2, stakeholder engagement and communication.
Okay, so building on that idea of the internal team, let's zoom out a bit. Think about the wider circle of influence. Stakeholders, they're absolutely critical. Our sources really stress this. Identifying, analyzing, and proactively engaging with stakeholders from the start to the end of the project helps to enable success.
Proactively engaging, so not just reacting when something goes wrong.
Exactly. It's not enough to just send out updates or deal with complaints. You have to actively seek their input, manage their expectations, build those relationships right from day one.
Okay, so this word engagement here, it sounds like it goes much deeper than just communication. Like sending emails isn't enough.
You're spot on. Engagement, as the source puts it, delves deeper to include awareness of the ideas of others, assimilation of other perspectives, and collective shaping of a shared solution. Think about those words. Assimilation, collective shaping.
Yeah, that's powerful.
It means it's not a one-way street. It's a real dialogue. You have to actually listen, absorb different views, and let them genuinely influence the project. It involves building solid relationships through frequent two-way communication. Things like interactive meetings, face-to-face meetings, informal dialogue, and knowledge-sharing activities.
So it's about making them partners, really, not just informing them.
Precisely. It's about co-creating the solution together.
That's a huge lesson for any kind of collaboration, honestly, not just building projects. It implies you really need to understand, the details of how, when, how often, and under what circumstances stakeholders want to be and should be engaged. You can't just use a generic approach for everyone. You have to tailor it.
Absolutely. Tailoring that engagement is key. Hashtag tag 1.3, tailoring leadership and planning approaches.
So, okay, we've got the team, we've got the stakeholders engaged. What about actually doing the work? The execution. I mean, projects vary so much. A small house renovation versus a massive bridge. Surely a one-size-fits-all approach to leadership or planning just won't work.
That's a really important point. The sources clearly state that tailoring of leadership styles is essential, and it's influenced by things like the team's experience with the type of project. For example, if you have a really experienced team that's done this kind of thing before, they might be more self-managing. They need less direct oversight, maybe more of a supportive leader.
Right, you wouldn't want to micromanage experts.
Exactly. But conversely, if it's a totally new type of project for the organization, or the team is less experienced, then you probably need a more directive leadership style, more guidance, more oversight. It's about matching the leadership to the situation.
Okay, that makes sense. And planning itself,
Yeah.
that can't be static either, right? I'm seeing discussions here about different ways to plan.
Definitely not static. There are distinct approaches. One model mentioned is doing high-level planning up front, followed by a design phase where prototyping is used. So you get the big picture sorted, then you iterate on the design, maybe build prototypes, and then you do the detailed planning once everyone agrees on the design.
Okay, so flexibility early on.
Yeah. Then there are also adaptive approaches where the project team conducts iterations. This is common in, say, tech or R&D. You might have a broad roadmap, but the detailed planning happens continuously at the start of each iteration or cycle. You adapt as you go based on feedback.
Right, because things change so fast.
Exactly. And here's where it gets really insightful, I think. They give specific examples, like construction projects require significant upfront planning. You need detailed plans for design, approvals, buying materials, logistics, delivery. You can't just wing it.
No, definitely not. You need to know where every pipe is going before you pour concrete.
Precisely. But then for product development or high technology projects, that continuous adaptive planning is often preferred. It allows for evolution, for changes based on feedback or new tech discoveries. You don't want a rigid plan holding you back. So it really shows how the nature of what you're delivering drives the how of your planning. It's pragmatic.
That's a key takeaway. Match the plan to the project. Hashtag tag 1.4 resources and continuous improvement. Okay, so beyond the people and the plans, projects need, well, we need stuff, right? Tangible things. What about those physical resources?
Good point. Physical resources are defined pretty broadly. It includes materials, equipment, software, testing environments, licenses, and so forth. Basically everything you need to actually build or create the thing. And planning for these resources, it's a huge deal. It involves estimating quantities, managing supply chains, figuring out logistics, procurement. Especially critical for projects with big physical components like engineering and construction. Getting the right materials to the right place at the right time, that's complex.
Yeah, I can imagine a delay in one key material could halt everything.
Absolutely. And procurement itself can range from just placing an order to managing these huge integrated activities across many suppliers.
And it sounds like you can't just set the plan and assume it'll all run smoothly. The documents talk about constant adaptation.
That's right. It reflects the reality that uncertainty and planning interact. Things happen. Risks emerge. So project teams are constantly planning how to deal with that uncertainty. Plans often need revision, or you might need totally new plans for unexpected events.
So being adaptable is crucial.
Yes. And what's really interesting here is the emphasis on implementing ongoing improvement. It's described as a 4-step process. First, pick an initial approach. Second, tailor it for your organization. Third, tailor it again for the specific project. And fourth, continuously improve it based on performance.
So it's a cycle. Learn and adapt.
Exactly. A dynamic feedback loop. You're constantly comparing performance to plans. And this ongoing process, it's not just about managing the current work. It's key to guiding the work, delivering the outcomes, and ultimately ensuring you get that business value.
So successful project management is really about agility, isn't it? Continuous learning and adjustment.
That's a great way to put it. Strategic agility.
Okay, let's shift gears a bit. Moving from the sort of abstract world of project management to the very concrete reality, pun intended, of what we build. Let's talk materials, the actual stuff buildings are made of.
Right, the fundamentals. And when we talk construction, some materials are just foundational. Let's take concrete. Our sources mention things like precast concrete slabs, beams, and structural tees. These are often made in a factory, not poured on site.
PG-casts are good.
Yeah, and they're often pre-stressed. This is a really clever technique. They basically put the concrete under compression before it takes any load, usually by tensioning steel cables inside it. Why do they do this? For greater structural efficiency.
So stronger for its size.
Exactly. You get less depth needed for the same strength, it's lighter, and you can span longer distances between columns. Huge advantage for big open spaces. It overcomes concrete's natural weakness and tension.
Clever stuff. And then you absolutely can't talk building without mentioning masonry, can you? Bricks, stone.
Oh, definitely not. Masonry is ancient. It's building with units like brick, stone, concrete block, usually held together with mortar. And what's amazing is how sophisticated they were about it, even way back. The mortar itself was critical. The sources talk about ancient builders choosing specific stones to make lime for mortar, like a spongy sort of stone for rough work, a scaly, rugged stone for weather exposure because it set quickly and lasted.
Wow, really specific choices.
Oh, yeah. And pebbles found in rivers for really white, neat mortar work. It shows this deep empirical understanding of material science honed over centuries. They knew their stuff.
Incredible. Okay, moving forward in time, steel. That changed everything, didn't it?
Massively. Steel combines high strength and stiffness with elasticity. It's considered the strongest, low-cost material available. Allows for incredible designs, tall buildings, long bridges, but crucial caveats. While it's incombustible, it won't burn steel, becomes ductile and loses its strength when subject to temperatures over 1,000 degrees Fahrenheit.
Ah, so fire is a major weakness.
A huge one. In a fire, steel structures can fail relatively quickly if unprotected. That's why in fire-resistant construction, it must be coated, covered, or enclosed with fire-resistant materials. Think gypsum board, spray-on fireproofing. Also, it corrodes, rust. So it must be painted, galvanized, or chemically treated for protection. Even tiny things like nails, if they're outside, need to be corrosion-resistant galvanized steel or aluminum alloy. Otherwise, the whole thing can be compromised over time.
Right, the details matter.
Yep.
Okay, and finally, wood. Maybe the oldest material of all, and still so common. The sources mention its moisture content can be huge, like 30% to 200% or more when growing.
Yeah, that's a vital point because pre-shrinking wood by seasoning is too important to pass over lightly. Wood shrinks as it dries, and it shrinks unevenly. If that happens after it's built into something.
Things warp, crack, joints open up.
Exactly. Big problems. So, seasoning drying the wood under controlled conditions aims to get that shrinkage done before it's used. The goal is a moisture content consistent with the average relative humidity of the place where the finished piece will be used. It's absolutely essential for stability and durability.
So much science, just in the basic materials. Hashtag perpetuate structural systems and their evolution.
And what's really captivating is how these materials, with all their different properties, are combined to create stable structures. The systems themselves have evolved over millennia.
Let's start with a classic structure lots of people recognize, the truss. You see them in roofs and bridges all the time.
Right. A truss is basically a triangulated structure. That triangulation is key. It allows for considerable spans to be roofed economically because it distributes the forces very efficiently, mainly into tension and compression in the members. A big benefit is it doesn't put dangerous outward thrusts on the supporting walls, unlike, say, a simple arch.
So it doesn't push the walls outwards.
Exactly. It converts bending forces into those simpler axial forces, which is super efficient for the material. You see it in steel railway bridges, timber barn roofs. The tied arch is mentioned as basically the same idea, using diagonals to resist shear forces.
Sheer, like forces trying to slide things past each other.
Precisely. Okay, now for concrete structures. We said concrete is great in compression, weak in tension. So how do they handle those tensile forces, especially in beams that have to bend? That's where reinforced concrete comes in. Steel reinforcing bars, or rebar. Ideally, you'd bend the steel bars to perfectly follow the lines of tension within the beam. That would be the absolute most efficient use of steel. But in practice, bending steel like that and holding it in place while you pour concrete is really, really difficult and expensive.
Yeah, I can picture that being fiddly.
Very. So a simpler rectilinear arrangement is substituted, usually straight bottom bars where the tension is highest, and then these loops called stirrups to handle shear forces, especially near the supports. It's a practical compromise. Still effective, much easier to build. Even things like foundation walls on dodgy soil might need rebar at both the top and bottom because they can act like beams bending either way.
It's fascinating how practicality shapes the engineering. And history must be full of examples of engineers making these kinds of choices.
Oh, absolutely.
Yeah.
Take Brunel's Maidenhead Bridge. 19th century, he used brick arches. Why? Probably because he was worried train vibrations would crack the brittle cast iron that was common for arches then.
Cast iron being brittle. Right.
Exactly. It's strong under steady load, but impact or vibration, not so good. Brunel's brick arches worked very well. They're still there. It shows you have to think about how the structure will be used, the specific stresses it will face, not just static strength. Material suitability is everything. Hashtag 2.3 modern construction planning and tools.
Okay, let's talk about managing all this complexity in modern construction. We've got diverse materials, intricate structures. How do we actually pull off these huge, complex projects today? Technology must play a massive role.
Oh, absolutely transformative. One of the biggest game changers is building information modeling BIM. BIM isn't just 3D drawing, it's way more. It defines a building as a composed set of objects.
Objects, like intelligent components.
Exactly. Every wall, pipe, window, beam, it's an object with data attached to it in a digital model. It's like a digital twin of the building. It changes everything, design, construction, even running the building later.
And the benefits sound huge.
Yeah.
I saw a mention of a study finding like 56 positive links between BIM and lean construction principles. That's aiming to cut waste, right?
That's right. BIM helps reduce variation because you can visualize form and evaluate function incredibly well. You can quickly generate and compare design alternatives. Crucially, it maintains information and design model integrity. Everyone works from a single information source, and it does automatic clash checking.
Clash checking, like finding where a pipe hits a beam in the model.
Precisely. Finding those problems before they happen on site, which saves enormous amounts of time and money fighting fires later. It also allows automated generation of reports. All this means more consistent and reliable information, which drastically reduces the waste of rework and of waiting for information. For owners, it allows conceptual cost estimating early and often, leading to much more informed design options.
So it optimizes the whole process, not just the design phase.
The entire life cycle. And then for the actual planning and scheduling, you have tools like critical path methods, CPM scheduling software, think Microsoft Project or Primavera. These tools sequence activities in space and time, show the links between tasks, and calculate the critical path, the sequence that determines the project duration, and also float values.
Float, like how much leeway a task has.
Exactly. How much an activity can slip without delaying the whole project? Smart managers use that float strategically. And this connects directly to lean construction. A key principle there is constraints analysis and removal. The idea is to make sure work that should happen can happen without blockages.
So finding and removing roadblocks proactively.
Yes. And those roadblocks can be anything. Physical, like needing a plotter before you can print drawings, or informational, like needing the soils report before designing the foundation. It's about clearing the path. And they track metrics like percent plan complete, PPC, to measure how reliable the workflow is. Are we actually doing what we plan to do this week? It fosters continuous improvement.
PPC.
Okay.
Measuring reliability. Makes sense. Hashtag tag 2.4 climate considerations and building envelopes.
Now, this brings us to something critical but often invisible: how buildings interact with the environment, especially moisture and air. It's not just about structure, it's about creating healthy, durable building envelopes.
Right, we always hear about insulation for energy efficiency, keeping heat in or out. But you're saying there are other things happening inside the walls.
Yes, and sometimes more serious problems. The sources mention a more pernicious issue than rain getting in: internally generated water vapor. Think about it. Since the 70s energy crisis, we've made buildings much more airtight and better insulated. Saves energy, great, but...
It traps moisture inside from people
Yeah.
breathing, cooking, showering.
Exactly. That moisture, as water vapor, gets everywhere. It moves through materials, looking for a cold surface to condense on. If it gets into your wall cavity and condenses there, it soaks insulation, corrodes metal parts, nails, screws, ties, and can drip down and rot the building's basic structure, all hidden from view. One source uses the striking image that the walls can become cheese.
Cheese, wow. Okay, that's not good. So just sealing everything up super tight isn't the answer then. It could trap the moisture.
Precisely. It's about smart design. The principle is building assemblies need to be protected from getting wet from the exterior and allowed to dry towards the interior. This involves carefully placed air barriers to stop drafts and vapor retarders to control moisture diffusion. But critically, you also need to avoid things like non-breathable vinyl wallpaper on the inside, especially in cold climates. That can act like a second vapor barrier and trap moisture in the wall.
So you need to let it breathe in a controlled way.
Controlled drying potential, yes. And it highlights how some design choices that seem good initially can have hidden long-term flaws.
Like what?
Well, the example given is cavity walls in brick construction. 2 layers of brick with a gap in between. Great for stopping rain penetration, water drips down the cavity, stronger, maybe cheaper. But the vulnerable component is the metal ties that reach across the cavity to hold the 2 layers together.
The ties holding it all together.
Yes. If those corrode over decades because of moisture trapped in the cavity, the wall weakens significantly. And the scary part is, there's no visible indication that there is any problem until parts of the outer layer fall off or the entire wall collapses. Inspection is crucial, and fixing it, putting in new ties can be horrendously expensive, shows the need for long-term thinking and design.
Definitely. Short-term gain, long-term pain potential. Okay, let's pull back again. We've gone from project management to material science, modern tools. It's clear that building is this incredibly complex dance, but how far back does this kind of thinking go? Let's dive into history a bit. Look at the roots.
Good idea. If we look back at ancient Rome, for instance, we see incredibly sophisticated construction. Even then, they mastered concrete, building small buildings circular in plan, covered with hemispherical vaults, think domes and round structures. They built amazing public baths, huge complexes, and of course the Pantheon, that vast circular hall with its massive concrete dome, still standing, still awe-inspiring. It shows their mastery of engineering and materials.
So the Romans were clearly phenomenal engineers, builders on a grand scale.
Admirable builders, as one source calls them. They really excelled at structure, figuring out how to build big. But there's an interesting critique mentioned that all that is not mere building in Roman edifices is Greek, Etruscan, or Asiatic, but not Roman. The argument is that while their engineering was top-notch, maybe their artistic forms were often borrowed or adapted, rather than being purely original Roman inventions. Masters of execution, perhaps, more than formal innovation.
That's an interesting perspective. Engineering versus artistic origin. Makes you wonder if we see that today sometimes.
It's a thought. And we have texts like Vitruvius's 10 books on architecture from that era, which give amazing insight into how they thought about building. It was really holistic.
Vitruvius.
Right.
What did he emphasize?
He stressed that an architect needed broad training, not necessarily a master of every science, but not unskillful in them, understanding geometry, optics, even medicine and law. He laid out detailed rules for temple design, proportions, aesthetics, but also super practical stuff like theater acoustics. He pointed out that without certain architectural elements like coronae bands partway up the walls, the voice of men engaged in discussion will be carried up and so be unintelligible. But with them, the voice is detained, making it clear.
Wow, so they were thinking about acoustics, about the human experience of sound way back then.
Absolutely. Designing for function, for how people actually used and experienced the space, not just how it looked. That's a really deep insight from antiquity. Hashtag tag 3.2, evolution of styles and forms. Medieval, classical, modern. Okay, so from those Roman foundations, things evolved. While Rome often applied existing forms to new structures, medieval France saw a different kind of shift. The arts there, driven by this societal fever, developed really systematic, rational, bold essays in construction. Think Gothic cathedrals. This was different from Rome, where apparently political revolutions and intellectual movements had no sensible effect on the arts. In medieval France, architecture seemed much more tightly woven into the cultural fabric.
So the culture itself was driving innovation in how they built. It wasn't separate.
Exactly. It was a reflection, an expression of the times. Think of Charlemagne trying to revive arts, bringing in artists, grammarians, manuscripts from Byzantium or Lombardy. Ideas spreading. Monasteries became crucial schools of art, places where knowledge could be preserved and developed. And you see practical innovation, too, like Abbot Sugar figuring out radiating chapels around the choir of his church. It solved a functional problem needing more altars, but created this stunning new architectural form that spread widely.
Radiating chapels.
Right.
You see those in Gothic churches.
Yeah. And the church chapters themselves were managing these huge projects dealing with land acquisition, financing, contracts. Pretty sophisticated stuff for the time.
And eventually, architects start to emerge as distinct figures, right? Not just anonymous builders.
Yes, like Villard Encore in the 13th century, sketching designs. We see the individual architect emerging. But even with all that medieval innovation, the influence of classical architecture never really went away. It kept coming back. Why? It was valued for its recognition and universality, its ability to transcend narrow symbolism, and crucially, to express power.
The power aspect, order, stability.
Exactly. Order, stability, grandeur, enduringness, that kind of monumental feeling, which is why it was often favored by authoritarian regimes. Hitler, for example, apparently boasted about connecting Hellenic serenity with the austere simplicity of modern functional architecture. It was partly a critique of the minimalist international style of modernism, which they felt failed to communicate on that level of timeless power.
Wow, so architectural style gets tangled right up in politics and ideology.
Deeply. Architecture is never just about buildings. It's about messages, power, culture. Hashtag 3.3, modern architectural thought in urban planning. So how do these big historical sweeps inform how we think about cities and buildings today? It's fascinating. Urban planning, for instance, is described as the last branch of architecture to reach full growth. It really only started developing new ideas around 1925, relatively recent in the grand scheme of things.
Which implies we're still figuring out how to best design our cities, our collective spaces.
Very much so. Modern architects are constantly reevaluating. Think of someone like Le Corbusier. In his book, Towards a New Architecture, he argued, a plan proceeds from within to without, for a house or a palace is an organism comparable to a living being. His focus was on the internal experience, the function, the life inside dictating the form, architecture from the inside out.
A building as an organism.
Okay. Then you have critics like Jane Jacobs looking at cities. She pushed back hard against rigid planning. She highlighted the economic value of old buildings as irreplaceable at will. You can't just tear everything down and build new identical blocks. She argued for good mixtures of primary uses, frequent streets, a close-grained mingling of different ages in their buildings, and a high concentration of people. Basically, messy, organic, diverse urban life.
Yeah, the opposite of sterile, single-use zones.
Exactly. She valued the complexity that evolves over time. And now we're talking about buildings that are almost like alive themselves.
Smart cities.
Yep.
Buildings talking to us.
That's the direction things are heading. Sensor networks can transform buildings into intelligent agents with the capacity to learn from and coexist with their occupants. They call it spatial cybernetics. Buildings that learn your habits, adjust lighting, temperature, maybe even guide you, merging the digital and physical.
Okay, that's both exciting and maybe a little unnerving.
Right, it raises huge questions. How do we make sure this tech serves us, enhances our lives, doesn't just create new problems or ways to control us? Neil Gershenfeld's Fab Lab idea, where machines will make machines, assemblers assembling assemblers, points to this accelerating tech curve. His point is we need an informed and engaged population to navigate this. We need to be architects of this future, not just passively accept it. Hashtag 3.4, the huge element in design and adaptation.
Okay, let's bring it all back home. Ultimately, buildings are for people, right? No matter how clever the tech or grand the design, it's about how we live in them, how they affect our behavior, our emotions, and how we, in turn, shape them.
Absolutely. And this idea that buildings learn because people learning is key. It suggests a bottom-up approach. It means giving significant design power to the individual users while they're using the place, not having everything dictated from the top down. Think about the historical contrast mentioned. The dark, cramped pit of a servant's kitchen versus the bright, spacious, centrally located kitchen for the family heads. Design reflects power in use.
So a bottom-up approach empowers users to adapt their space.
Ideally, yes. Make it genuinely responsive, like that anecdote about the Fab Lab kitchen.
Right. Tell us that again.
Nicole Gershenfeld initially said you can't have a kitchen in a Fab Lab. It wasn't part of the technical plan. But then he saw how people actually use the space and concluded you can't have a Fab Lab without a kitchen, because the kitchen became the hub, the community lifeblood, fostering those informal chats and collaborations essential to how the lab really worked.
That's brilliant. The unplanned use became vital.
Exactly. It shows how spaces adapt to real human needs. We see similar thinking in modern office design now, realizing acoustic privacy is often more important than visual privacy for focused work, leading to layouts like cave and commons. Yeah, private caves for concentration and open commons areas for interaction, catering to different needs within the same space.
That human-centric view.
Yeah.
It really connects with someone like Frank Lloyd Wright, too, doesn't it? His whole philosophy.
Oh, very much so. Wright was famously critical of conventional educational methods focused on rote learning. He wanted independent thought, creativity, and a deeper understanding of design and nature. He saw his buildings as more than just shelter. They were meant to inspire hope, to be in tune with their environment, to connect people to nature, and foster a better way of living.
A very deep, almost spiritual connection to architecture.
Yes. Which brings us full circle, really. We can celebrate the existential pleasures of engineering, the joy of building amazing things, but there's also that warning voice. Technology, if we're not careful, can cut us off from the natural world, lead to a denatured, that is to say, dehumanized state. So the ultimate goal, perhaps, when we design and build, it's not just about structure or looks or even efficiency. It's about creating environments that truly support us, support clear communication, focused work, peaceful rest, by understanding human needs, respecting nature, and making sure our creations genuinely enhance the human experience. Hashtag tag tag outro.
Wow. What an incredible journey through these sources, from the nitty-gritty of project management and collaboration,
Yeah, the stakeholder engagement, the tailored leadership.
all the way to the grand sweep of architectural history, the properties of materials like concrete and steel, and how they shape what's possible.
And those deep philosophical questions about what buildings mean, how they affect us.
It really shows how every decision, big or small, truly shapes the world we inhabit every day.
I think so too. These sources, though they seemed separate at first, they really wove together this rich tapestry, didn't they? They show that great projects, lasting structures, inspiring buildings, they don't just happen by accident. They're the result of really thoughtful planning, skilled work, understanding materials deeply, and having that appreciation for the human experience, past, present, and future. Being well-informed, I guess, means seeing all those connections.
Yeah, and that idea that a building should be a joy for all the senses, not just look good. As we keep weaving digital tech into our physical spaces, smart homes, smart cities, we really are called to be the architects of that future, aren't we? Not just let it happen to us.
We have to be intentional.
Which leaves a big question for you, our listener, to think about. As things keep changing so fast, how do we make sure that what we build and how we build it truly reflects the best of our ingenuity and care? How do we create spaces that don't just shelter us, but actually nourish our spirits and improve our collective well-being, both for people and the planet?
A profound challenge.
It really is.
Oh.
We hope this deep dive has given you a fresh perspective, maybe some new ways to look at the complex, sometimes messy, but ultimately beautiful and deeply human endeavor of building.